Now we can see. Now you can start. Now you can start.
Okay, fine. Fine. Yes. To pass a chip or to tape out or to do some production, we have to do few checks. Those are like CD, lint, synthesis, and PD. If we are cleared with those steps only, we can go for the next step. So in previous classes, I have gone through CDC, and today I'm going to explain about lint. What is lint? See, mainly here, why do here? 1 minute. Yes. So what all the topics here I'm going to cover in today's class is like introduction, and what are the inputs and outputs we are going to give lint, goals of lint, what are the errors we are going to find it out, and the for each error the brief, what is that? See, if the tool throws it's a fatal error, what all the checks we are going to do in that fatal, if it is a bit match. So like that, for each error I'm going to give you a brief topic on this. So first is an introduction. So what is an introduction in the sense? What is a lint and why do we use it? So lint is nothing but it is a process of static code analysis of RTL design. Nothing but we will be having an RTL design, right? So what the lint tool does, it will analyze the RTL. That what is an analyzation? It will check the RTL whether the RTL design is following particular guidelines, rules, or any practices. That means the given RTL design is correct or not. For the checking for that process is known as lint. Why do we use lint? We use lint to check whether the RTL is synthesizable or not. First, what is the process of lint? What is the process of lint? It is a process of analyzing an RTL design. Nothing but the lint tool analyzes the RTL to check whether to check the quality of the code or whether it is following the guidelines or rules of the coding. All these checks under the lint. And why do we use lint? We use lint whether the RTL is synthesizable or not. Since say whether the RTL is used for doing a work or not, that for that purpose we use a lint. This is introduction. And what are the inputs? See, for everything we need an input and output, right? So if we are a human beings, if we want to get an energy, we need some input, that is a food. In the same way, even the tool lint, see, without any input the tool doesn't work. We have to give some stuff, or we have to dump something in the tool. So what are the input we are going to give in a lint? We are going to give library files, waiver files, .v files, stc files. All these comes under the input. Library file means all the library file contains like cell information, input, output, pose information. All the file information comes in the library file. Waiver file it doesn't use in a files are known as waiver file. So what are the inputs we are going to give to a lint? Library. The output, the tool runs something, or the tool runs, it will check all the static checks and it will do all the process, and finally it gives some output, right? So what are output we are getting is that report. In that report it contains, if there is an error in that report we can find it out, and all the reports were thrown in this lint. 1 minute. Yeah, report files are the outputs of lint. So the next topic is goals of lint. See, I told you that what is a lint? It is a process of checking an RTA whether it is whether it is following rules, guidelines, and all, and we are using whether it is. So what is a goal? See, if it doesn't do a lint, what happens? We can go directly and we can go for synthesis, we can go for PD, and we can go for other steps and all. No, so what are the goals of lint? Why we are doing lint? Lint must review in the sense it will review all the RTL design. Next, it must fix according to the specification. See, the designer or the client will have some specification, right? But the design may have some mistakes. See, we human being makes the RTL design was written by our human being. Human beings may make some mistakes. So the lint, with the help of the lint, we will be checking, or we will be verifying the client specification. Next, lint should be as per the design. According to the design, we have have to perform a lint. So these are the goals of lint. Lint must review, lint must fix according to the specification. If you have any errors, we should fix according to the specification given by the client or given by the people. Next, lint should be as per the design. So see, which we can't completely modify the design. According to the design, the small inputs or small outputs we will be adding and we will be changing it. Next, see, we are doing all this. See, we are giving input, we are giving output, we are doing everything. So when the tool runs, each and if we are having some any errors, the tool throws some errors. So what all the errors we are going to get in a real-time experience? See, here we will be getting some fatal errors, bit mismatch errors, undriven input and output terminal, combinational circuit connected as a flop, combinational circuit connected as a reset, unfurled latches, and black box. See, we are running a lint. We are going through all the process of the lint, like taking the inputs from the library file. We are running each and every step. After running each and every step, the final step is that it gives some report. So in that report, we will be having errors. So if it doesn't have error, lint will be passed. If it have errors, it will throw what all the errors, like fatal errors. So what all the errors it will throw? Fatal errors, bit mismatch errors, input undriven input and output terminal, combinational circuit connected as a flop, combinational circuit connected as a reset, inferred latch, and black box. These are the mainly common errors which we can see in a real-time experiences. See, when we keep on working in a client project, some of the errors we will be seeing. Mostly we will be seeing bit mismatch errors, inferred latches errors, but in undriven input are rare we can see, but mostly we can see bit mismatch, inferred latches, and fatal errors we can see in the real time. So let me explain you on brief what are fatal, what is bit mismatch, what is undriven input output, what are combinational circuit connected as a flop or reset, and what. So first let me explain you what is fatal error. What is a fatal error? See, when the RTL was not when the RTL was when the RTL was run by the the tool throws an error called fatal error. See, we are giving an RTL design as an input, right? So when the tool runs, the tool do an error called fatal errors. So what does it contains? What is a fatal error? That means what we should check for fatal errors. That means if we have any compile issues, if we have any syntax issues, if the RTL was not proper. For these all the reason, the tool throws an error with a single name called fatal syntax. You shouldn't say like that. It will in the it all together and gives one name, that is a fatal error. We have to understand when the tool gives a fatal error, we should understand, oh, somewhere in a code we are having some syntax error, somewhere in a code the design is not proper, somewhere in a code we are having some compile issues. Like that we have to think and we have to correct. That is a fatal error. And the second one is bit mismatch error. What is a bit mismatch error? See, here we will be having some assigned bits will be there. See, for a particular input it should have some 8 bits, it should have some 4 bits, it should have some 2 bits, like that it will be having. So whenever there is a bit mismatch error, when we compare for input to output, or when we compare for flop to flop, we are giving 2 bit, it becomes it become a 1 bit data, there is a loss of 1 bit data. So that the bits were matching, so that in that case the tool threw as an error called bit mismatch error. And data width will be there, no pulse width and logic, if these are not proper, and the tool throws under a error called bit mismatch error. And the third one is undriven input and output terminal. What is an undriven input and output terminal? Here we'll be sending an input signal, right? Here if an input signal doesn't have a defined value, once in a while the RTL design there will be a lot of mistake, right? If there is any value which was not, any particular value which was not assigned to the input signal, in that cases the design shows an unpredictable behavior, and at that time the tool gives an error called undriven input terminal. If it is an input side, it gives an input terminal. If it is an output side, it gives us a output terminal. And the next one is combinational circuit connected as a flop or a flop or a reset. See, we'll be having a combinational circuits, we will be having a sequential circuits, everything will be having in a design. We'll be having cells, macros, TF cells, library cells, everything will be having in a design, right? So if we have a combo logic, if it lacks an ability to retain its state or information, the combo logic, it should be a constant. Either it should be like it should perform 0 means it should perform 0. If it is a high means it should be going to high. If it doesn't retain a same information, that means if it receives any wrong information, in that state the combo logic may connected to a flop or the combo logic may connected to reset, and that is through a combinational circuit connected as a flop or combinational circuit connected as a reset. Next one is inferred latches. What is an inferred latches? See, we are having a combinational logics or we are having a combinational circuits. When the output of a combinational logic is in an undefined stage, that means it not be a 0 or it need not be a 1. It will be an undefined stage, like it a metastability state. The output may be an unpredictable state. In that cases, it reaches through inferred latches. See, if you have used a Xilinx tool, when we keep on doing a Verilog, for example, for if we write a small code for any marks or AND gate or gate, if we doesn't give any particular output properly, in that case the Xilinx tool gives you an error. When it go for a simulation, it gives, when you go for a behavioral structure check, it will gives you a some error called inferred latches. In the sense, we have to understand that output was not having a defined proper defined value. In that case, we should identify and we should check. So this is the brief on errors. Fatal error mean any syntax error, compiling issues, or whatever the, if the RTL design was not proper, that comes under fatal error. And bit mismatch error means if we have an incorrect bit or if we have a data width is not proper, the logics were not at all proper, that comes under bit mismatch error. Undriven input and output terminal, in the sense, if an input signal or an output signal doesn't have a defined value when they are sourcing or when they are driving, in that cases it leads to undriven input and output terminal. Next, combinational circuit connected as a flop or a reset, in the sense, if the combo logic lacks to retain its original state or it lacks to retain its original information, in that cases it is wrongly connected to a flop and wrongly connected to a reset. That means if it is connected wrongly, only with the value we have, the received value will be in a, the received state will not be retained a original state. Next, inferred latches, in the sense, when an output of a combinational logic, it is an indefined stage. That means it not be a 0, it not be, it is in a unpredictable stage. In that cases, it guide through a inferred latches. So these are the errors and these are the brief on errors. So this is a short topic. Lint is nothing but it's a short topic. So I'm just giving you some questions which are based regarding on interview. And when you face an interview based on, say, if you mention like CDC, I know CDC, I know lint, or I know synthesis in a resume, you may fall some question in lint, like why do we use lint? Why do we use lint? In the first topic I have to, we use mainly lint to check whether the RTL is synthesizable or not. You can get this question in a different way, like what is the use of lint? Same, you to check the static codes or to check whether it is following a proper coding guidelines or not, and it is used for checking whether the RTL is synthesizable or not. All these answers are to the first query, refers to the first question. Next, what are the inputs given to our lint? What are the inputs? Library files, path files, next waiver files, all the inputs of the lint. Next, what are the outputs we get from the lint? Only just a normal reports we get from the lint. Next, what are the goals of lint? Lint must review, lint must be fixed according to the specification, lint must be checked according to the design. Next, explain errors explain errors comes in the scenario of link. See, when you attend an interview, you may get a question like, can you please explain? Can you please explain of errors which you experience? Like fatal, bit mismatch, undriven terminal, combinational terminal. No need to say all the things. You can just mention any 2 or 3 errors which you are very perfect and confident. So they may ask you that. See, bit mismatch, you may say that bit mismatch error. So what is a bit mismatch error? You will explain that. How did you correct it? How did you correct that bit mismatch error? So you can say, see, for particular line, I have a bit mismatch error, like input, it is this much of bit, this much of bit I have got. So there I have just went and I have reported, or I have corrected there. You can explain like that. If you have any like if you have a confident on a particular error, you can mention only those 2 errors, so that gives a better answer to the interviewer. So these are the questions in the link. So this is a small topic. If you have any doubts, you can just ask me, so that anyone are having a doubt, you can just ask me. It is just a short topic and very very easy topic which you can easily put into your resume, and you can even easily score. You can easily answer to the interviewer, because it's a short topic. You doesn't have a lots of questions in this. They'll just ask you, what is a lint, why do we use a lint, what are the inputs, what are the outputs, and next, what is a tool you have used here. You can I didn't explain you regarding tool. What is a tool? Spyglass lint, you can explain. Next, what are the errors you have seen in a real time experience? Only these are the few questions. If you learn this topic, it's very easy topic. Nothing is there to learn in this. Just a basic thing. If you just remember, if you put in your resume, it gives a advantage for each and everything. CDC, link, synthesis, if you pass all these only, you can go for the PD, ST and timing analysis. So first, these checks are very 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 important. After link, we'll be going for synthesis, and after synthesis, we'll be going for timing analysis, PD. So when you pass this link only, we can go for the next step. Why do we? You can ask a question, what is a, without doing a link, there may be some errors in a coding. If you go this give this complete design to the next team, that is a synthesis team, the synthesis will not run it through all the errors, and it becomes so difficult for those people. So that's why, to avoid that, we will perform CDC and link before itself. Not. So it is very easy topic. If you learn it, if you go through it, you can mention in your resume without no any doubt. You can answer to the question which your interview can ask. So if you have any doubt, you can raise me a question, so I'll clear you that. It's not only for this lint, is not only for DV, it's for everything, like RTL design people, it is for DV, it is for PD people, if it is for STA people, for all the people, this lint is very very important. This is a basic concept, right? So when you put to a resume, it adds a weight on that. That's it. So if you have any doubt, you can just raise a question. It's clear? If you have yes, tell me.
Ma'am, what are the linting tools available for us?
See, when you go for an interview type, you can just say them Spyglass tool. So Spyglass lint tool very very easy to operate. Lazilin, Spyglass is there. Spyglass lint is very easy to operate. So you can say Spyglass lint. I have used Spyglass lint. If you say, it's enough. It's very easy to operate.
But is it available open source or?
No, it's not an open source. It's a licensed one. We doesn't get. When you go for an real hands-on experience, or when you take a VLSI coaching centers, they will provide you the software version.
Okay.
Yes.
Ma'am, how to get experience of using linting tool?
Only
See, we will be having
only a theory part is enough for the beginner, right? Once you get into the industry, they will give the license tools, right? Because Spyglass and Jasper Gold are very very expensive, right? And
Yes,
that is not
yes,
even
it's
needed. That is not even needed, right?
yes.
But now it is
Yeah,
not.
if it is like
Hmm.
okay, fine, fine. I'm just to say you the procedure like what how to use a tool. See, we will be having a design which was given by the client, and that design is dumped already in our tool. When we get an access, we have to by using some GUI commands. So when you come for a client or when you come for a working source, you will be having some GUI commands. Based on the GUI commands, you should dump and run. So after running, you should check all the it for running. It takes 2 to 3 days. After running, you should check for behavioral check, simulation check, everything. In that way, you can take, but it is very expensive to get a spyglass tool. Yes. Any other question? See, if you people need any topic, you can just say me so that I can explain you or I can give you a like overview of that topic which is useful for your interview basis. You can suggest me a topic, ma'am, we need this topic, or ma'am, we need that topic. I'll be giving you through that. See, CDC I have done. See, I'm not going to the depth. I'm going you giving you a overall thing which you can remember easily in a point of an interview. I'm just going you in the point of an interview, not in a point of other way. You people can understand, right? So when you face an interview, it becomes an easy for you. So in the point of an interview, I'm just preparing a PPT in a shorter way. In the same way, I'm giving you question at the last slide. So if you can have that, ma'am, if we have this topic, it be more useful, I can go through that. Can anyone have an idea on that? And if you can ask me, I'll give you on that a demo on that, a class on that. No any doubts? No any topics to ask?
AXI, how is it about the AXI? Can we do the AXI in the next class?
AXI, yeah?
Yeah.
Okay, I'll just prepare it and I'll let you know.
Yeah. There are different versions are there. AXI Lite and different things are there.
Yeah. Yes, we have a lot of that basic thing I know, like what
Yeah,
are the
yeah.
read channel, what are the write channels, and how do we source for it, what is a master, what is a slave, all those I know it. But the different methods I don't know, but I'll just go
Or
through it and I'll let you
or
know.
you can cover the complete Amba also. That is also fine. That will be taking more class,
Okay, fine.
but you can take
Okay,
the
so
more.
one thing I can do that. See, one thing I can do. I see I have completed CDC now lint, and then I can go for synthesis,
Yeah,
then
no problem.
STA,
Yeah.
then I'll go for STA.
Yes. That is also
Yeah,
fine.
so it is on an order, systematic order. When you go
Yes.
for so a company, it's a systematic order: CDC, lint, synthesis, timing analysis, STA, PD, then inserting a DFT target. So these are
Yeah.
all orders. So after completion this, I'll go for an AXA and AMBA,
Yeah.
any
Okay.
protocol.
Yeah. Sure. Thank you, ma'am.
Okay,
Thank you, ma'am. Thank you.
sure. Yes. Okay.